The Invisible Spark, Joseph Henry and the Rise of Industrial Electricity. Good day, everyone. Today, I would like to share the remarkable story of a scientist whose work helped shape the electrical world we live in today. His name was Joseph Henry, a brilliant American physicist whose discoveries laid the foundation for many modern electrical technologies. Although his name is not as widely recognized as some other scientific pioneers, his contributions were essential to the rise of industrial electricity. Joseph Henry was born on December 17, 1797, in Albany, New York. Growing up in modest circumstances, he developed a strong interest in learning and science. His natural curiosity encouraged him to explore the mysteries of nature, leading him toward a career that would eventually transform the field of electricity. Joseph Henry was one of the most influential scientists in the history of electricity, yet his journey began in a very ordinary way. Before he became a pioneer of electromagnetism and helped lay the foundations for modern electrical technology, he was simply a curious young boy growing up in a world that was very different from the one we know today. Understanding Joseph Henry's early life helps us appreciate how determination, education, and curiosity can transform an individual into a person whose discoveries change the world. Joseph Henry was born on December 17, 1797, in Albany, New York, in the United States. America was still a young nation at the time. The country was developing its identity, industries were limited, and scientific knowledge was expanding slowly compared to modern standards. Most people lived simple lives, and opportunities for advanced education were not always available. Despite these challenges, the environment of discovery and innovation that existed in the young nation would eventually help shape Henry's future. His parents were immigrants from Scotland. Like many immigrant families of that era, they worked hard to support their household and provide opportunities for their children. However, life was not always easy. Financial difficulties affected the family, and Joseph experienced challenges that could have discouraged many young people. Instead of allowing these hardships to limit his ambitions, he developed a strong sense of perseverance and self-reliance. During his childhood, Joseph spent part of his early years living with his grandmother in Galway, New York. This rural environment exposed him to nature and practical problem solving. Life in the countryside required observation, patience, and creativity. Children often learned by watching adults work with tools, machinery, and everyday tasks. Although Joseph did not yet know that he would become a scientist, these experiences helped cultivate habits of careful observation that would later become valuable in his scientific career. As a young boy, Henry did not immediately show signs that he would become a famous physicist. In fact, his interests were quite diverse. He enjoyed reading and was fascinated by stories and literature. Like many children, he was curious about the world around him and eager to learn new things. His imagination was active, and he often explored ideas beyond what was taught in ordinary lessons. One of the most important influences on Joseph Henry's intellectual development was his love of books. Books opened doors to worlds that he could not physically visit. Through reading, he encountered new ideas, different cultures, and scientific concepts that stimulated his imagination. At a time when access to information was limited, books served as powerful tools for education and inspiration. Interestingly, Henry's first major passion was not science but theater. As a teenager, he developed a strong interest in acting and stage performance. He enjoyed dramatic literature and even considered pursuing a career in theater. For a period of time, he devoted significant attention to this interest and imagined a future on the stage. This aspect of his life demonstrates that successful scientists do not always follow a straight path toward their careers. People often discover their true calling through exploration and experience. The turning point in Henry's life came when he encountered a book that sparked his interest in science. The book discussed natural philosophy, a term used during that era to describe the study of nature and the physical world. Reading about scientific ideas awakened a new sense of curiosity within him. He became fascinated by the laws that governed natural phenomena and began asking questions about how the world worked. This transformation was significant. Instead of focusing solely on literature and theater, Henry started investigating scientific subjects. He became interested in mathematics, physics, chemistry, and other areas of knowledge. The more he learned, the more he wanted to discover. His curiosity became a driving force that shaped the direction of his life. Unlike many students today who have access to advanced laboratories, computers, and extensive educational resources, Henry often relied on self-education. He studied independently, read whatever scientific materials he could find, and worked hard to understand complex concepts. This habit of self-directed learning became one of his greatest strengths. Joseph Henry eventually enrolled at the Albany Academy, one of the most respected educational institutions in New York at the time. The Academy provided opportunities for talented students to receive a strong education. Here, Henry encountered teachers who recognized his abilities and encouraged his intellectual growth. At Albany Academy, he excelled in mathematics and science. His teachers noticed that he possessed an unusual ability to understand difficult subjects. More importantly, he did not simply memorize information. He wanted to understand why things worked the way they did. This desire to uncover deeper explanations distinguished him from many of his peers. The educational environment at Albany Academy played a crucial role in developing Henry's scientific mindset. Students were encouraged to think critically, conduct observations, and solve problems. These experiences helped prepare Henry for the experimental work that would later define his career. Another important factor in Henry's development was his mechanical skill. He enjoyed building and repairing objects, which allowed him to connect theoretical knowledge with practical applications. This combination of intellectual curiosity and hands-on experience would become one of the hallmarks of his scientific achievements. Many great scientists possess the ability to visualize how abstract principles operate in the real world. Henry demonstrated this talent early in life. When he learned about scientific concepts, he often thought about how they could be applied to practical problems. This approach enabled him to move beyond theory and develop innovations that had real, world value. As he continued his studies, Henry became increasingly fascinated by the emerging field of electricity. During the early 19th century, electricity was one of the most exciting areas of scientific research. Scientists across Europe and America were making discoveries that revealed the surprising properties of electrical forces. New experiments demonstrated that electricity could produce light, heat, and motion. These developments captured Henry's imagination. He realized that electricity represented a frontier of knowledge with enormous potential. While many questions remained unanswered, he saw opportunities for discovery and innovation. His growing interest in electricity marked the beginning of a lifelong commitment to scientific exploration. The period during which Henry lived was characterized by rapid intellectual change. New scientific discoveries were challenging traditional assumptions and expanding humanity's understanding of nature. Advances in chemistry, physics, astronomy, and engineering were transforming society. Henry found himself at the center of this exciting era of progress. His curiosity extended beyond simply learning established facts. He wanted to contribute new knowledge to the world. This ambition motivated him to conduct experiments and seek answers to unanswered questions. Rather than accepting limitations, he viewed challenges as opportunities for investigation. An important lesson from Henry's early life is the value of persistence. He faced financial difficulties, limited resources, and uncertainty about his future. Yet he continued pursuing education and self-improvement. His success demonstrates that determination and curiosity can overcome many obstacles. The support of mentors and educators also played a significant role in his development. Teachers who recognized his potential encouraged him to continue studying and exploring scientific subjects. Their guidance helped nurture his talents and provided opportunities for growth. Henry's story illustrates how curiosity often begins with simple questions. Why does a magnet attract iron? How does electricity move through a wire? What forces govern the natural world? These questions may seem ordinary, but they can lead to extraordinary discoveries when pursued with dedication and creativity. By the time he completed his education, Joseph Henry had developed a strong foundation in mathematics, science, and experimental thinking. He possessed the skills necessary to investigate complex problems and contribute to the advancement of knowledge. Although he had not yet achieved fame, the qualities that would make him a great scientist were already evident. His early experiences taught him the importance of observation, critical thinking, and perseverance. These lessons would guide him throughout his career and enable him to make groundbreaking contributions to electromagnetism and industrial electricity. The transformation from a curious child in Albany to an ambitious young scholar demonstrates the power of education and intellectual curiosity. Henry's journey reminds us that scientific achievement often begins with a desire to understand the world. Great discoveries are rarely the result of sudden inspiration alone. They emerge from years of learning, questioning, and persistent effort. As Joseph Henry entered adulthood, he stood at the threshold of a remarkable career. The curiosity that had been sparked by books, nurtured by education, and strengthened through self-study was about to lead him toward discoveries that would influence communication, industry, and technology for generations to come. The early life of Joseph Henry, therefore, serves as more than a historical introduction. It provides valuable lessons about the importance of curiosity, determination, and lifelong learning. His story encourages us to remain open to new ideas, embrace challenges, and pursue knowledge with enthusiasm. These qualities not only shaped Henry's success, but continue to inspire scientists, inventors, and students around the world today. As Joseph Henry moved from his years as a student into early adulthood, his curiosity became stronger and more focused. The foundation built during his childhood and education now began to influence the direction of his career. He was no longer simply learning scientific knowledge from books. He was preparing to contribute to science himself. This transition marked an important stage in his development and set the course for the achievements that would later make him one of the most respected scientists in American history. After completing his studies at Albany Academy, Henry initially considered several career paths. During this period, opportunities in science were limited compared to modern times. Scientific research was not always a full-time profession, and many educated individuals worked as teachers, engineers, surveyors, or in other occupations while pursuing scientific interests. Henry understood that he would need both practical skills and academic knowledge to build a successful future. One of the first professions he explored was surveying. Surveyors played a crucial role in the development of the United States by measuring land, creating maps, and supporting construction projects. This work required precision, mathematical ability, and careful observation. Henry's training in mathematics made him well suited for such tasks. Through surveying, he gained valuable experience in measurement and problem solving, skills that would later benefit his scientific experiments. At the same time, Henry continued studying scientific subjects independently. He believed that learning should never stop after formal education ended. This attitude reflected a lifelong commitment to intellectual growth. Whenever he encountered a new idea, he sought to understand it thoroughly. Whenever he faced a difficult problem, he viewed it as an opportunity to learn rather than a reason to give up. Eventually, Henry became associated with Albany Academy as a teacher. This position proved highly important in his personal and professional development. Teaching required him to explain complex concepts clearly and accurately. In doing so, he deepened his own understanding of scientific principles. Many scientists discover that teaching strengthens their knowledge because it forces them to organize information logically and communicate it effectively. As an instructor, Henry quickly gained a reputation for intelligence, dedication, and creativity. He wanted his students to think critically rather than simply memorize facts. Instead of presenting science as a collection of rules, he encouraged inquiry and experimentation. This approach reflected his own belief that genuine understanding comes from exploration and observation. During the early 19th century, scientific discoveries related to electricity and magnetism were attracting increasing attention. Researchers throughout Europe and America were investigating mysterious connections between electric currents and magnetic forces. In 1820, the Danish physicist Hans Christian Ørsted demonstrated that an electric current could influence a magnetic needle. This discovery revealed a previously unknown relationship between electricity and magnetism. The scientific world responded with great excitement. Researchers realized that an entirely new field of study had emerged. Among those fascinated by these developments was Joseph Henry. He carefully studied reports of electrical experiments and began conducting investigations of his own. Henry possessed an important advantage. He combined theoretical understanding with practical craftsmanship. He was skilled at designing and constructing experimental equipment. Rather than relying entirely on instruments made by others, he often built or modified devices himself. This ability allowed him to test ideas in innovative ways and pursue experiments that might otherwise have been impossible. His curiosity drove him to ask questions that many people overlooked. Why did some electromagnets perform better than others? How could electrical forces be strengthened? Could electricity be transmitted efficiently over long distances? These questions reflected both scientific interest and practical thinking. Henry was not satisfied with understanding natural phenomena alone. He wanted to explore their potential applications. One characteristic that distinguished Henry from many researchers was his patience. Scientific progress often requires repeated experimentation, careful measurements, and willingness to learn from mistakes. Henry understood that important discoveries rarely occur instantly. He spent long hours testing ideas, analyzing results, and refining his methods. This dedication to experimentation was rooted in habits developed during childhood. The same curiosity that once inspired him to explore books and observe nature now motivated him to investigate electrical phenomena. His early experiences had taught him to pay attention to details and remain persistent when facing challenges. Another significant influence on Henry's growth was the scientific community of his era. Although communication was slower than today, scientists exchanged ideas through letters, publications, and meetings. Henry followed developments occurring in Europe and America, learning from the work of other researchers while contributing his own insights. The culture of scientific collaboration helped accelerate progress. Researchers built upon each other's discoveries, creating a chain of knowledge that advanced understanding. Henry respected the achievements of fellow scientists and recognized that science thrives when ideas are shared openly. Despite his growing expertise, Henry remained humble. He viewed science as a continuous search for truth rather than a competition for personal recognition. This attitude earned him the respect of colleagues and students alike. His willingness to learn from others contributed significantly to his success. As his knowledge expanded, Henry became increasingly aware of the potential importance of electricity. Although practical electrical technologies were still limited, he sensed that electricity could one day transform society. He imagined applications that extended beyond laboratory demonstrations and scientific curiosity. This vision was remarkably forward-thinking. During Henry's lifetime, electricity was still largely experimental. Few people could have predicted the vast electrical systems that would eventually power industries, cities, and communication networks. Yet Henry recognized that fundamental discoveries made in the present could shape the future. His early investigations into electromagnetism reflected this broader perspective. He sought not only to understand electrical phenomena, but also to explore how they might be harnessed for practical purposes. This combination of scientific curiosity and practical imagination became a defining feature of his career. The support of educational institutions also played a role in his development. Albany Academy provided resources, facilities, and opportunities that enabled him to conduct experiments. Access to equipment and intellectual exchange allowed his ideas to flourish. These experiences demonstrate the importance of educational environments in nurturing scientific talent. As Henry continued his work, he developed confidence in his abilities as a researcher. Each experiment increased his understanding and strengthened his determination. Successes encouraged further exploration, while setbacks provided valuable lessons. Through this process, he acquired the skills necessary for major scientific achievements. His journey highlights the importance of lifelong curiosity. Many individuals stop asking questions once they complete formal education, but Henry never lost his desire to learn. Whether reading scientific literature, conducting experiments, or teaching students, he remained driven by a passion for discovery. This curiosity also influenced his character. It encouraged open-mindedness, creativity, and resilience. Rather than fearing uncertainty, Henry embraced it. Unanswered questions did not frustrate him, they inspired him. He understood that every mystery represented an opportunity for knowledge and innovation. By the late 1820s, Joseph Henry was emerging as a promising scientist. His reputation within academic circles was growing, and his experiments were attracting attention. The foundations established during childhood and education had prepared him for greater challenges and accomplishments. The story of Henry's early life demonstrates that scientific greatness is often built gradually. It begins with curiosity, develops through education, and grows through persistence. Small moments of learning accumulate over time, eventually leading to significant achievements. Henry's career illustrates this process clearly. His experiences also remind us that talent alone is not enough. Success requires dedication, discipline, and a willingness to continue learning. Henry's achievements were not simply the result of intelligence. They were the product of years of effort and determination. As he moved beyond this formative stage of life, Henry was ready to make contributions that would influence the development of electricity and communication. The curious boy who once dreamed of a career in theater had become a serious scientist, prepared to explore one of the most exciting frontiers of human knowledge. The lessons from Joseph Henry's early life remain relevant today. Curiosity encourages innovation. Education opens doors to opportunity. Persistence transforms potential into achievement. These principles helped shape Henry's journey and continue to guide individuals who seek to make a positive impact on the world. By understanding the origins of Joseph Henry's scientific career, we gain insight into the qualities that enabled him to become a pioneer of electromagnetism. His early experiences provided the foundation upon which all his later accomplishments were built. Without the curiosity, determination, and love of learning that characterized his youth, the remarkable contributions he made to industrial electricity might never have occurred. Thus, the story of Joseph Henry's early life is not merely a chapter in the history of science. It is an inspiring example of how a curious mind, supported by education and strengthened through perseverance, can help change the course of human progress. The story of Joseph Henry's scientific career is closely connected to one of the most important discoveries in human history: the relationship between electricity and magnetism. Today, electromagnetism powers countless technologies, from electric motors and generators to telecommunication systems and industrial machinery. However, during the early 19th century, the nature of electricity and magnetism remained largely mysterious. Scientists knew that electrical charges and magnetic forces existed, but they did not fully understand how these phenomena were connected. Joseph Henry entered this exciting period of scientific exploration and played a crucial role in revealing the extraordinary power of electromagnetism. To understand Henry's achievements, it is important to first examine the scientific environment of his time. In the late 18th and early 19th centuries, electricity was still a developing field of study. Researchers conducted experiments using batteries, electrical charges, and simple circuits, but practical applications remained limited. Electricity was often viewed as an interesting scientific curiosity rather than a force capable of transforming society. Magnets, on the other hand, had been known for centuries. People understood that magnets could attract iron and influence compass needles. However, magnets seemed entirely separate from electricity. Most scientists considered them different natural phenomena governed by unrelated principles. This perception changed dramatically in 1020, when the Danish physicist Hans Christian Ørsted made a groundbreaking discovery. During a classroom demonstration, Ørsted observed that a compass needle moved whenever an electric current passed through a nearby wire. This observation revealed a direct connection between electricity and magnetism. Electric currents could create magnetic effects. The discovery shocked the scientific world. Researchers immediately recognized its significance and began investigating the relationship between electrical and magnetic forces. New experiments appeared across Europe and North America as scientists attempted to understand this newly revealed phenomenon. Among those deeply fascinated by Ørsted's findings was Joseph Henry. At the time, Henry was a teacher and researcher with a growing interest in experimental science. The discovery captured his imagination because it suggested that electricity possessed powers far greater than previously imagined. Rather than simply accepting existing explanations, Henry decided to conduct his own investigations. One of Henry's greatest strengths was his ability to combine theoretical understanding with practical experimentation. He did not limit himself to reading scientific reports. Instead, he built devices, tested ideas, and carefully observed results. This hands-on approach allowed him to explore electromagnetism in ways that many others could not. When Henry began studying electromagnetism, scientists had already created simple electromagnets. An electromagnet, it consists of a coil of wire through which electric current flows, producing a magnetic field. Early electromagnets demonstrated the principle successfully, but their strength was relatively limited. Henry wondered whether they could be improved. This question became the starting point for some of his most important discoveries. Henry believed that stronger electromagnets could reveal new possibilities for science and technology. To achieve this goal, he carefully examined how electromagnets were constructed and searched for ways to enhance their performance. One innovation involved the use of insulated wire. At the time, many electromagnets used uninsulated wire, which restricted the number of coils that could be wrapped around an iron core. Henry realized that insulating the wire would allow multiple layers of coils without electrical interference. This seemingly simple improvement dramatically increased the strength of electromagnets. The results were remarkable. Henry succeeded in building electromagnets far more powerful than those previously constructed. His devices could lift much heavier objects and produce stronger magnetic effects. These achievements demonstrated that electromagnetism was not merely a scientific curiosity, but a powerful force capable of performing useful work. The construction of stronger electromagnets represented more than a technical improvement. It provided evidence that electrical energy could be controlled and amplified. This realization had profound implications for future technologies. If electricity could create powerful magnetic forces, it might eventually be used to operate machines, transmit information, and perform industrial tasks. Henry's experiments also deepened scientific understanding of electromagnetic principles. Through careful observation, he identified relationships between wire coils, electrical currents, and magnetic strength. His findings helped establish a foundation for later developments in electrical engineering and physics. An important aspect of Henry's work was his willingness to experiment repeatedly. Scientific progress rarely occurs through a single experiment. Instead, it requires persistence, patience, and attention to detail. Henry spent countless hours testing different configurations, adjusting equipment, and analyzing results. Each experiment provided new information that guided future investigations. His laboratory became a place of discovery where questions were transformed into knowledge. Rather than being discouraged by failures, Henry viewed unsuccessful experiments as opportunities to learn. This attitude enabled him to make steady progress even when challenges arose. As his electromagnets became more powerful, Henry began exploring additional questions. Could electrical signals travel over long distances? Could magnetic effects be produced remotely? Could electricity serve practical purposes beyond laboratory demonstrations? These questions reflected Henry's broader vision. He was not interested solely in understanding natural laws. He wanted to discover how those laws could benefit society. This combination of scientific curiosity and practical thinking distinguished him from many contemporaries. One particularly important discovery involved the transmission of electrical signals over extended distances. Henry demonstrated that electrical currents could travel through long wires and activate electromagnets at remote locations. This achievement suggested that information might one day be transmitted rapidly across great distances. At the time, communication relied largely on physical transportation. Messages were carried by people, horses, ships, or other means that required time and effort. The possibility of transmitting information electrically represented a revolutionary concept. Although Henry did not develop a complete telegraph system himself, his experiments provided crucial scientific foundations for later communication technologies. By proving that electrical signals could travel long distances and produce useful effects, he helped make the telegraph possible. His work also contributed to a broader understanding of electromagnetic induction. Electromagnetic induction refers to the generation of electrical currents through changing magnetic fields. This principle would later become essential for electric generators and power production systems. While other scientists such as Michael Faraday also made major contributions to the study of induction, Henry independently explored similar phenomena. His investigations expanded scientific knowledge and strengthened the theoretical framework of electromagnetism. The significance of these discoveries cannot be overstated. Modern electrical systems depend fundamentally on electromagnetic principles. Electric motors convert electrical energy into mechanical motion using magnetic forces. Generators produce electricity through electromagnetic induction. Transformers, communication devices, and countless industrial machines rely on related concepts. When Henry conducted his experiments, however, these technologies did not yet exist. He was investigating a frontier of knowledge whose practical implications were only beginning to emerge. His ability to recognize the importance of electromagnetism demonstrated remarkable scientific insight. Another reason Henry's work was influential is that he communicated his findings to the broader scientific community. Through publications, lectures, and correspondence, he shared knowledge that allowed other researchers to build upon his discoveries. Science advances through collaboration, and Henry understood the value of contributing to collective understanding. His reputation grew steadily as colleagues recognized the quality of his research. Scientists in America and Europe admired his experimental skills and respected his contributions. Although he worked during a period when American science was less developed than European science, his achievements demonstrated that significant discoveries could emerge from the United States as well. The study of electromagnetism also influenced Henry's philosophy of science. He believed that scientific knowledge should ultimately serve humanity. Discoveries were valuable not only because they expanded understanding, but also because they could improve lives. This perspective motivated him to explore practical applications of electrical principles. As industrialization accelerated during the 19th century, society increasingly required new sources of power, communication, and technological innovation. Henry's research provided tools that helped meet these needs. Strong electromagnets, electrical signaling methods, and improved understanding of electromagnetic forces all contributed to technological progress. The phrase, "the power of electromagnetism," can be understood in multiple ways. It refers not only to the physical force produced by electrical currents, but also to the transformative impact of electromagnetic technologies on society. Henry recognized both dimensions of this power. His discoveries demonstrated that invisible forces could perform visible work. Electrical currents flowing through wires could generate magnetic fields strong enough to lift heavy objects or activate distant devices. This ability to convert invisible energy into practical action captured the imagination of scientists and inventors alike. Moreover, electromagnetism revealed a deeper truth about nature. Seemingly separate phenomena could be interconnected. Electricity and magnetism were not isolated forces, but aspects of a unified system. This realization represented a major step forward in humanity's understanding of the physical world. Joseph Henry's exploration of electromagnetism therefore combined scientific curiosity, technical innovation, and visionary thinking. Through his experiments, he transformed abstract concepts into practical possibilities. He showed that electricity could be controlled, strengthened, and applied in useful ways. By the end of this phase of his career, Henry had established himself as one of the leading investigators of electromagnetism. His work laid essential foundations for future advances in communication, transportation, manufacturing, and energy production. Although many later technologies would be developed by other inventors and engineers, they relied heavily on principles that Henry helped uncover. The discovery of the power of electromagnetism marked a turning point not only in Henry's life, but also in the history of science and technology. It opened the door to innovations that would reshape industries, connect continents, and power modern civilization. Joseph Henry stood among the pioneers who first revealed the extraordinary potential hidden within electrical and magnetic forces. His achievements remind us that great scientific breakthroughs often begin with simple questions and persistent experimentation. By seeking to understand the connection between electricity and magnetism, Henry helped unlock one of the most powerful forces ever harnessed by humanity. As Joseph Henry continued his investigations into electricity and magnetism, he became increasingly convinced that electromagnetism held enormous potential. His early successes with stronger electromagnets encouraged him to pursue more ambitious experiments. Each discovery revealed new possibilities and strengthened his belief that electricity could become one of the most important forces in science and industry. One of the most remarkable aspects of Henry's work was his ability to recognize opportunities that others often overlooked. Many researchers viewed electromagnetism primarily as a scientific phenomenon worthy of study. Henry certainly appreciated its scientific significance, but he also saw practical applications that could transform society. This forward-looking perspective allowed him to explore questions that would eventually influence communication, transportation, manufacturing, and electrical engineering. As he experimented with electromagnets, Henry observed that increasing the number of wire coils around an iron core significantly enhanced magnetic strength. He carefully tested different arrangements, battery configurations, and wire lengths. Through systematic investigation, he learned how various factors affected performance. These experiments required patience and precision because even small changes could alter results. The powerful electromagnets Henry created attracted widespread attention. Some of his devices could lift hundreds and even thousands of pounds, achievements that amazed scientists and the public alike. Demonstrations of these electromagnets provided dramatic evidence of the practical power hidden within electrical currents. What had once seemed like an invisible and mysterious force was now capable of performing impressive physical work. Such demonstrations were important because they changed perceptions about electricity. Before these advances, many people considered electricity a subject for scientific curiosity rather than practical use. Henry's work helped convince observers that electrical forces could be harnessed for real-world applications. This shift in thinking contributed to growing interest in electrical technologies. Another significant area of Henry's research involved long-distance electrical transmission. He wanted to determine whether electrical signals could travel through extended lengths of wire while still producing useful effects? This question was critical because practical communication systems would require signals to travel far beyond laboratory distances. To investigate, Henry conducted experiments using long wires connected to batteries and electromagnets. He demonstrated that electrical currents could travel considerable distances and activate devices at remote locations. This finding represented a major breakthrough. It suggested that information could potentially be transmitted almost instantly across large areas. The implications of this discovery were profound. Throughout most of human history, communication depended on physical transportation. Messages traveled only as fast as people, animals, ships, or vehicles could carry them. Electrical communication promised something entirely different: the near-instant transmission of information. Henry's experiments became an essential foundation for the development of the telegraph. Although Samuel Morse would later create a successful telegraph system and gain widespread recognition, the scientific principles underlying telegraphic communication were supported by Henry's earlier research. His demonstrations showed that electromagnets could respond to electrical signals sent through long wires, making practical telegraphy possible. Importantly, Henry was motivated more by scientific discovery than personal fame. He freely shared his findings with other researchers and inventors. This openness accelerated technological progress because it allowed others to build upon his work. Rather than guarding knowledge for personal advantage, he viewed science as a collective effort to advance human understanding. His contributions extended beyond communication. Henry also explored the phenomenon now known as self-inductance. In simple terms, self-inductance occurs when changes in electrical current create effects that influence the current itself. Although the concept may appear technical, it became highly important in electrical engineering and later electrical technologies. Henry observed these effects during experiments involving coils and circuits. His investigations helped reveal that electrical systems could exhibit complex behaviors influenced by magnetic fields. These insights expanded scientific understanding and contributed to the development of more advanced electrical devices. At roughly the same time, scientists in Europe, particularly Michael Faraday, were making related discoveries concerning electromagnetic induction. Although Henry and Faraday worked independently, their research complemented one another. Together, their findings helped establish the foundations of modern electromagnetism. The relationship between Henry and Faraday highlights an important aspect of scientific progress. Major discoveries often result from the efforts of multiple researchers working in different locations. Each scientist contributes pieces of understanding that eventually combine into a broader picture. Henry's role in this process was both significant and influential. As his reputation grew, Henry became recognized as one of America's leading scientists. His experiments were discussed internationally, and researchers across the Atlantic followed his work with interest. At a time when European institutions dominated scientific research, Henry demonstrated that American scientists could make important contributions to global knowledge. The success of his electromagnets also inspired inventors to imagine new machines and technologies. Engineers began considering how electromagnetic forces could power devices, control mechanisms, and automate processes. These ideas would eventually lead to electric motors, relays, signaling systems, and numerous industrial innovations. One particularly important invention influenced by Henry's work was the electromagnetic relay. A relay uses a small electrical signal to control a larger electrical circuit. Henry demonstrated principles that contributed directly to relay technology. Relays later became essential components in telegraph systems, telephone networks, industrial control systems, and early computers. This development illustrates how fundamental scientific research often produces practical benefits that may not be immediately obvious. Henry's experiments were motivated by curiosity about natural phenomena, yet they eventually influenced technologies used by millions of people. His work serves as an example of how scientific inquiry can generate long-term societal value. Another reason Henry's discoveries were important is that they revealed the scalability of electromagnetism. Small laboratory experiments could be expanded into larger systems capable of performing useful tasks. Stronger electromagnets, longer wires, and improved batteries allowed researchers to move beyond demonstrations toward practical applications. Industrial leaders began recognizing the economic potential of electrical technologies. Factories sought more efficient methods of operation. Communication networks required faster transmission of information. Transportation systems demanded improved control mechanisms. Electromagnetism offered solutions to many of these challenges. Although large-scale electrical industries had not yet fully emerged, Henry's research helped prepare the way. By demonstrating what electricity could accomplish, he encouraged inventors and entrepreneurs to pursue new possibilities. His discoveries served as stepping stones toward future technological revolutions. An important characteristic of Henry's approach was his commitment to careful observation. He avoided drawing conclusions without evidence and relied on experimental results to guide his understanding. This scientific discipline strengthened the reliability of his findings and earned the trust of fellow researchers. His work also reflected creativity and imagination. Scientific progress requires more than technical skill. It requires the ability to envision possibilities beyond existing knowledge. Henry's willingness to ask unconventional questions enabled him to discover phenomena that others might have missed. As electromagnetism became better understood, scientists gradually recognized its role as a fundamental force of nature. The connection between electricity and magnetism revealed a deeper unity within the physical world. This realization represented one of the most important intellectual achievements of 19th-century science. Henry contributed significantly to this transformation in understanding. His experiments provided evidence that electrical and magnetic effects were intimately connected. By exploring these relationships, he helped establish principles that remain central to physics today. The practical impact of these discoveries continued to grow throughout the 19th century. Telegraph networks spread across countries and continents. Electrical devices became increasingly sophisticated. Industrial machinery incorporated electromagnetic components. Eventually, electric power generation and distribution systems emerged, reshaping modern civilization. While later inventors such as Thomas Edison and Nikola Tesla became famous for commercial electrical technologies, their achievements rested upon scientific foundations established by earlier pioneers like Joseph Henry. Without Henry's contributions, many later developments would have been delayed or made more difficult. The phrase "discovering the power of electromagnetism," therefore, describes both a scientific journey and a technological awakening. Henry helped reveal that electricity could do far more than produce sparks or shocks. It could generate motion, transmit information, control machinery, and support entire industries. By the end of this stage of his career, Henry had become one of the foremost authorities on electromagnetism. His experiments expanded scientific knowledge, inspired technological innovation, and demonstrated the practical value of electrical research. He transformed electromagnetism from an emerging scientific curiosity into a field with enormous industrial potential. The legacy of these discoveries continues today. Every electric motor, power generator, transformer, communication network, and countless electronic devices rely on principles connected to electromagnetism. Modern civilization depends heavily on concepts that Henry helped explore nearly 2 centuries ago. Joseph Henry's work reminds us that revolutionary technologies often begin with fundamental scientific questions. His curiosity about the relationship between electricity and magnetism led to discoveries that changed the course of history. Through persistence, creativity, and rigorous experimentation, he helped uncover one of nature's most powerful forces and paved the way for the electrical age that followed. In understanding Henry's exploration of electromagnetism, we gain insight not only into a remarkable scientist, but also into the process of discovery itself. His achievements demonstrate how knowledge grows through observation, experimentation, and imagination. They also show how invisible forces, once understood, can become powerful tools that shape the world. The rise of industrial electricity owes much to Joseph Henry's determination to uncover the secrets of electromagnetism and reveal its extraordinary potential to humanity. Building stronger electromagnets, one of Joseph Henry's most important contributions to science, was his work in building stronger electromagnets. During the early 19th century, electromagnetism was a new and exciting field of study. Scientists had recently discovered that an electric current flowing through a wire could create a magnetic field. While this discovery was groundbreaking, the electromagnets available at the time were relatively weak and had limited practical use. Joseph Henry recognized that if electromagnets could be made more powerful, they might become valuable tools for science, industry, and communication. Henry began studying the design of existing electromagnets and searching for ways to improve them. He realized that the strength of an electromagnet depended largely on how the wire was wrapped around an iron core. Many early electromagnets used simple wire arrangements that produced only modest magnetic forces. Henry experimented with different methods and discovered that using insulated wire allowed multiple layers of coils to be wrapped around the iron core without causing electrical interference. This innovation greatly increased the magnetic strength of the device. Through careful testing and experimentation, Henry succeeded in creating some of the most powerful electromagnets of his era. His improved electromagnets were capable of lifting objects much heavier than those lifted by earlier designs. In one famous demonstration, an electromagnet built by Henry lifted thousands of pounds, astonishing scientists and observers. These achievements proved that electricity could be harnessed to perform significant mechanical work. Henry's work was important because it transformed electromagnets from scientific curiosities into practical tools. Stronger electromagnets opened the door to many new applications. They became essential components in telegraph systems, electric motors, relays, generators, and industrial machinery. By showing that magnetic force could be greatly increased through improved design, Henry helped establish the foundation for many technologies that would later shape the modern world. Another significant aspect of Henry's research was his scientific method. He carefully observed results, tested different configurations, and refined his designs based on evidence. Rather than accepting existing limitations, he continuously searched for better solutions. His persistence and creativity allowed him to achieve breakthroughs that others had not imagined. The stronger electromagnets developed by Joseph Henry also contributed to the advancement of communication technology. They made it possible for electrical signals traveling through long wires to activate devices at distant locations. This principle became a key element in the development of the electric telegraph, which revolutionized communication by allowing messages to be transmitted rapidly across great distances. Today, the influence of Henry's work can still be seen in countless electrical devices. Modern motors, transformers, speakers, relays, and industrial machines all rely on electromagnetic principles. Although technology has advanced far beyond the equipment available in Henry's time, the basic ideas he helped develop remain essential. In conclusion, Joseph Henry's efforts to build stronger electromagnets were a major milestone in the history of science and technology. His innovations demonstrated the practical power of electricity, expanded scientific understanding, and laid the groundwork for many of the electrical systems that support modern life. Through determination, experimentation, and ingenuity, Henry helped unlock the vast potential of electromagnetism and contributed significantly to the rise of industrial electricity. Contributions to the telegraph revolution. Joseph Henry played a vital role in the development of the telegraph, one of the most revolutionary communication technologies of the 19th century. Although he did not invent the telegraph itself, his scientific discoveries provided many of the principles that made long-distance electrical communication possible. His work in electromagnetism laid the foundation upon which later inventors, especially Samuel Morse, built practical telegraph systems. For this reason, Joseph Henry is often regarded as one of the key scientific pioneers behind the telegraph revolution. Before the invention of the telegraph, communication over long distances was slow and difficult. Messages had to be carried by people, horses, ships, or other forms of transportation. Depending on the distance, delivering important information could take days, weeks, or even months. This limitation affected governments, businesses, newspapers, and ordinary citizens. Society needed a faster and more reliable way to communicate. Joseph Henry's experiments with electricity and electromagnetism helped provide the solution. While studying electromagnets, he discovered that electrical currents could travel through long wires and still produce useful effects at distant locations. He demonstrated that an electric signal sent through a wire could activate an electromagnet far away from its source. This finding was extremely important because it proved that electrical communication over long distances was possible. One of Henry's most significant contributions was his development of powerful electromagnets and electromagnetic relays. A relay is a device that uses a weak electrical signal to control a stronger electrical circuit. Henry showed that electromagnets could be used to strengthen and repeat signals traveling through long wires. This innovation solved a major problem in long-distance communication, as electrical signals naturally weakened over distance. By using relay principles, signals could be extended much farther than previously thought possible. These discoveries directly influenced the development of the electric telegraph. Samuel Morse, who is often credited as the inventor of the practical telegraph, relied on scientific principles that Henry had already demonstrated. Henry's research provided evidence that electrical signals could travel great distances and activate mechanical devices. Without this knowledge, building an effective telegraph system would have been far more difficult. Henry was also generous in sharing his scientific findings. Rather than keeping his discoveries secret, he published his results and communicated with other researchers and inventors. This openness allowed technological progress to move forward more quickly. When Morse sought advice and support during the development of his telegraph system, Henry encouraged the project and acknowledged its potential value. The success of the telegraph transformed society. Messages that once required days or weeks to deliver could now be transmitted in minutes. Governments could communicate rapidly across large territories, businesses could coordinate operations more efficiently, and newspapers could report events much faster than before. The telegraph connected cities, regions, and nations in ways that had never been possible. Joseph Henry's contributions therefore extended far beyond the laboratory. His discoveries helped create the scientific foundation for a communication revolution that changed the world. By proving that electricity could transmit signals across long distances, and by developing stronger electromagnets, he made modern telecommunications possible. In conclusion, Joseph Henry's role in the telegraph revolution was both significant and lasting. Although others commercialized the technology, Henry's research supplied the essential scientific principles that allowed the telegraph to succeed. His work demonstrated the practical power of electromagnetism and helped usher humanity into a new age of rapid communication. The telegraph revolution stands as one of the greatest examples of how Henry's scientific discoveries contributed to technological progress and the rise of industrial electricity. The invisible spark behind industrial electricity, Joseph Henry, is often described as the invisible spark. Behind industrial electricity, because his scientific discoveries provided the foundation for many electrical technologies that transformed industry and modern life. Although he did not become as famous as inventors such as Thomas Edison or Nikola Tesla, Henry's research in electromagnetism made many later innovations possible. His work revealed how electricity could be controlled, transmitted, and used for practical purposes, helping to usher in the age of industrial electricity. During the early 19th century, electricity was still largely a scientific curiosity. Researchers knew that electrical currents could produce interesting effects, but few practical applications existed. Joseph Henry saw enormous potential in this mysterious force and devoted much of his career to understanding how electricity and magnetism interacted. Through careful experimentation, he discovered ways to strengthen electromagnets and improve the transmission of electrical signals. One of Henry's greatest achievements was the development of powerful electromagnets. By using insulated wire wrapped in multiple coils around an iron core, he created electromagnets far stronger than those previously built. These devices demonstrated that electrical energy could be converted into powerful mechanical force. This breakthrough was important because it showed that electricity could do useful work, making it valuable for industrial applications. Henry's experiments also proved that electrical signals could travel through long wires and activate devices at distant locations. This discovery became a key principle behind the telegraph, which revolutionized communication during the Industrial Revolution. Faster communication allowed businesses, factories, railways, and governments to coordinate activities more efficiently, helping industries expand and operate on a much larger scale. Another important contribution was Henry's work on electromagnetic induction and relay systems. His research helped scientists and engineers understand how electrical currents and magnetic fields interact. These principles later became essential in the design of generators, transformers, motors, and other electrical equipment. Modern power systems depend heavily on these technologies, making Henry's discoveries fundamental to industrial development. The rise of industrial electricity changed the world in profound ways. Factories that once relied on manual labor or steam engines gradually adopted electrically powered machinery. Electrical systems improved manufacturing efficiency, increased productivity, and supported the growth of large-scale industries. Communication networks expanded, transportation systems improved, and new technologies emerged. While many inventors contributed to these advancements, the scientific groundwork established by Joseph Henry played a crucial role. Henry's influence extended beyond his laboratory research. As the first secretary of the Smithsonian Institution, he promoted scientific education and encouraged innovation throughout the United States. He believed that scientific knowledge should benefit society and inspire future generations of researchers and inventors. His leadership helped strengthen the nation's scientific community during a period of rapid technological progress. The term invisible spark is particularly appropriate because Henry's contributions were often behind the scenes. He was primarily a scientist rather than a businessman or entrepreneur. His discoveries were not always visible to the public, yet they powered many of the inventions that followed. Like a spark that ignites a larger fire, his research helped initiate developments that transformed industry and society. In conclusion, Joseph Henry was a key figure in the rise of industrial electricity. Through his pioneering work in electromagnetism, signal transmission, and electrical theory, he provided the scientific foundation for many technologies that shaped the modern world. Though often overlooked, his contributions were essential to the electrical revolution, making him truly the invisible spark behind industrial electricity. Scientific leadership and lasting influence. Joseph Henry was not only a brilliant scientist and pioneer of electromagnetism, but also an outstanding scientific leader whose influence extended far beyond his own discoveries. Throughout his career, he demonstrated a deep commitment to advancing scientific knowledge, supporting education, and encouraging innovation. His leadership helped shape the development of American science during the 19th century, while his discoveries continued to influence generations of scientists, engineers, and inventors. For these reasons, Joseph Henry's scientific leadership and lasting influence remain an important part of his legacy. One of the most significant moments in Henry's career came in 1846, when he was appointed the first secretary of the Smithsonian Institution. The Smithsonian had been established to promote the increase and diffusion of knowledge, and Henry was chosen to lead the new organization because of his reputation as a respected scientist and educator. He believed that scientific research and education were essential for the progress of society, and he worked tirelessly to ensure that the Smithsonian became a center for learning and discovery. As secretary, Henry encouraged scientific investigations across a wide range of fields. He supported researchers, promoted the exchange of scientific information, and helped create networks that connected scientists throughout the United States and abroad. At a time when American science was still developing, his efforts played a crucial role in strengthening the nation's scientific community. He understood that progress depends on cooperation, communication, and the sharing of knowledge. Henry was also a strong advocate for scientific education. He believed that young people should have opportunities to learn about science and develop their curiosity about the natural world. Through lectures, publications, and educational programs, he helped make scientific knowledge more accessible to the public. His commitment to education inspired many students and future researchers to pursue careers in science and engineering. Another important aspect of Henry's leadership was his willingness to support the work of other inventors and scientists. Unlike some individuals who sought personal recognition above all else, Henry believed that scientific progress should benefit humanity as a whole. He openly shared his discoveries and encouraged others to build upon them. His support for innovations such as the telegraph demonstrated his belief in collaboration and the practical application of scientific knowledge. The influence of Joseph Henry's scientific work continued long after his lifetime. His research on electromagnetism contributed directly to the development of electric motors, generators, transformers, communication systems, and countless other technologies. Modern electrical power systems depend on principles that Henry helped discover and explain. Every time electricity is used to power a machine, transmit information, or operate industrial equipment, the influence of his work can be seen. In recognition of his contributions, the International Unit of Electrical Inductance was named the Henry in his honor. This scientific unit serves as a permanent reminder of the impact he had on the field of electricity and magnetism. It is rare for a scientist to have a unit of measurement named after them, and this distinction reflects the importance of Henry's achievements. Beyond science and technology, Henry's legacy includes the values he demonstrated throughout his life. He showed the importance of curiosity, perseverance, integrity, and service to society. He believed that knowledge should be used to improve the world, and that scientific discoveries should be shared for the benefit of all people. In conclusion, Joseph Henry's scientific leadership and lasting influence extended far beyond his laboratory experiments. Through his work at the Smithsonian Institution, his support for education and research, and his groundbreaking discoveries in electromagnetism, he helped shape the future of science and technology. His contributions continue to impact modern life, making him one of the most influential scientific leaders of the 19th century. Joseph Henry's legacy in the modern world. Joseph Henry's contributions to science and technology continue to influence the modern world in countless ways. Although he lived during the 19th century, the discoveries he made in electromagnetism remain fundamental to many of the electrical systems and technologies that people use every day. His pioneering research helped establish the scientific principles behind electric power, communication systems, and industrial machinery. As a result, Joseph Henry's legacy extends far beyond his own lifetime and remains deeply connected to modern civilization. One of Henry's most important contributions was his work on electromagnets. By developing stronger and more efficient electromagnets, he demonstrated that electricity could be transformed into powerful mechanical force. Today, this principle is used in electric motors, generators, relays, transformers, and many other devices. Electric motors power household appliances, factory equipment, transportation systems, and industrial machines around the world. The technology behind these systems can be traced back to the early experiments conducted by Joseph Henry. His influence is also evident in modern communication networks. Henry's research showed that electrical signals could travel through long wires and activate devices at distant locations. This discovery helped make the telegraph possible and laid the groundwork for future communication technologies. Although modern systems now use advanced electronics, fiber optics, satellites, and wireless networks, they are still based on the idea of transmitting information through electrical signals. In this sense, Henry's work contributed to the development of telephones, radio, television, computers, and the Internet. Another area where Henry's legacy remains visible is electrical power generation and distribution. Modern power plants rely on electromagnetic principles to produce electricity. Generators convert mechanical energy into electrical energy through electromagnetic induction, a process closely related to the scientific concepts Henry helped explore. Once electricity is generated, Transformers and transmission systems distribute power to homes, businesses, hospitals, schools, and industries. These technologies are all connected to the foundational principles of electromagnetism that Henry studied. Joseph Henry also left an important legacy through his leadership in scientific education and research. As the first secretary of the Smithsonian Institution, he helped establish one of the world's most respected centers for knowledge and discovery. His efforts encouraged scientific collaboration, research, and public education. The Smithsonian continues to promote learning and innovation, reflecting Henry's vision that science should benefit society and inspire future generations. The scientific community has honored Henry's achievements by naming the International Unit of Electrical Inductance the Henry. This unit is used by engineers, physicists, and students worldwide when studying electrical circuits and electromagnetic systems. Having a scientific unit named after him is a lasting tribute to the significance of his work and ensures that his name remains part of modern science. Beyond his technical achievements, Henry's life offers valuable lessons about curiosity, perseverance, and innovation. He showed that great discoveries often begin with simple questions and a desire to understand how the world works. His dedication to research and learning continues to inspire scientists, engineers, inventors, and students across the globe. In conclusion, Joseph Henry's legacy in the modern world is both profound and far-reaching. His discoveries in electromagnetism helped create the foundation for modern electrical technology, communication systems, and industrial development. Through his scientific leadership, educational contributions, and lasting influence on technology, Henry played a vital role in shaping the world we live in today. His work remains a powerful reminder that scientific knowledge can transform society and improve the lives of future generations.